We are going to start this video creating our first NumPy array. We'll call it first array, and this is how we create it, using the array function from the NumPy library. And inside we'll give it as argument the data that this array will contain. For example, if we give it a vector with the values 1 and 2, what we get is a vector of 2 elements. But in this case, what we'll do is create a matrix with 2 rows. To do that, we create a list of lists with the first and the second row. And inside the first row, we'll declare the elements that will be in it: 10, 9, 8, 7, and 6. And on the second row, the elements will be 5, 4, 3, 2, and 1. We'll store this array in the first array variable, and we'll show it in the cell output. Let's run this cell, and here it is. A 2-row matrix as we described. The first row will have these 5 elements, and the second row these 5 elements. The number of dimensions of the array that we just created is stored in the ndim property. And as you know, since we've created a matrix, the number of dimensions is 2. We have the vertical dimension, where you see the different rows, and the horizontal dimension, where you see the different columns. NumPy libraries also have another property called size. The size property tells us the total number of elements inside that array. In this case, it will be 10, because we have 2 rows of 5 elements each. And NumPy arrays also store their shape in a property. As you can see, this array has 2 dimensions, with 2 elements in the first dimension and 5 on the second. That is 2 rows and 5 columns. We can access the elements of the array using indices. For example, let's imagine that we want to access the first row. Then we simply index the array using the value 0. Just as we would do to access the first element of a Python list. In NumPy, we can use one index if we want to access an element of the first dimension, or we can use more indices if we want to specify the exact element that we want to access in more than one dimension. For example, if we use the indices 1 and 2, what we get is the number 3, which corresponds to the element in the first row, counting from 0, and the second column, also counting from 0. It corresponds to these 3 right here. And we reach this element giving the array an index for each one of its dimensions. In this way, we can access the element that we're interested in, or even we can access a slice of the original array by giving only the index of a subset of the dimensions of the array. In the previous example, we gave the array the index 0, and that gave us a whole row, because we didn't specify a value for the column dimension. Another thing we can do is pass the array a value for one dimension and a range for another dimension. For example, in the first dimension, we'll pass 1, and in the second dimension we'll pass the range from 0 to 4. What does this mean? Well, what it means is that we are going to select from the second row, that is, the row with index 1, the elements corresponding to the columns 0 to 4. That is, columns 0, 1, 2, and 3, because the fourth column is not included. We can even use ranges in both dimensions. For example, we can use the index 0, which means that we want to select all the rows from the first one until the last one, and we can index the columns from 1 to 3, and that will give us the elements of the second and third columns of the array. That is, indexing the array in this way, we'd get the values 9, 8, 4 and 3. Furthermore, as in Python lists, we can give the array negative indices. This here means that we'll select all the columns counting to 3 from the end, from this element until the end of the array. And we can also index NumPy arrays using Boolean values. That is, values that are true or false. We can create an array with Boolean values that will tell us the elements that we want to select and the elements that we want to exclude. This array has Boolean values, and it tells us which elements of the original array are greater than 4. 10 is greater than 4, 9, 8, etc. All these values will be true up to here, because here is where the value 4 is located in the original array. And we can use this Boolean array to select the elements that we need from the original array. And we'll do it in this way. We'll pass this Boolean array instead of the numerical indices that we passed before. And what we'll get is an array that only includes the elements that we selected. And now we're going to see a last method to index NumPy arrays. We are going to create a variable called evenArray whose elements will be true only if the elements of the original array are even. Here it is. 10 is an even number, 9 is not, 8 is an even number, etc. And now we're going to use the non-zero function from the NumPy library and we'll give it this Boolean array as argument. Let us execute the cell, and here it is. As you can see, the result is a tuple of arrays, and these are arrays that tells us the indices of the original array where the even condition is met. That is, the element 0, 0, this one here, which is 10 in the original array, satisfy the condition of being even. The element 0, 2, that is 8, also satisfies this condition. The element 0, 4, which is 6 in the original array, also satisfies it, and so on and so forth.